A standard highway bridge is posted for 80,000 pounds. The first machine on this list weighs 1.3 million pounds fully loaded. That is not 2 times the legal limit. That is 16 times the legal limit. On 4 wheels. These 5 machines are not banned from public roads because someone wrote a bad regulation. They are banned because the road fails before the machine does. Ground pressure, axle loading, structural width. Physics does not negotiate. We are not doing this for spectacle. Understanding why these are banned teaches you how roads actually fail and how engineers prioritize job site performance over pavement. 40 years in this industry. I have run iron in open pit mines, highway construction, and heavy lift.
Come on, let's get into it.
Machine number 1. The Caterpillar 797F Ultra Class Haul Truck. The numbers first. Operating weight empty, 623,000 pounds. Payload capacity, 400 short tons. Gross vehicle weight at full load, approximately 1.3 million pounds. Engine, a Cat C175-20 V20 diesel producing 4,000 horsepower at 1,750 RPM and over 14,000 foot-pounds of torque at the crankshaft. The truck is 31 feet wide, 23 feet tall, and 49 feet long. Why it cannot go on a public road starts with ground contact pressure. A fully loaded semi at 80,000 pounds on 18 tires puts down roughly 100 to 110 pounds per square inch on the road surface. Highway asphalt is designed to absorb that. The 797F runs on 6 tires, each one 13 feet tall, with a contact patch roughly the size of a dining room table per tire. The ground pressure those tires put down is calibrated for compacted mine haul roads built from engineered fill and crushed aggregate. On standard bituminous highway asphalt, the surface does not crack. It peels. The subbase fails underneath it. You do not leave tire tracks. You leave trenches. From the operator's seat, the 797F is a different world. The cab sits 25 feet off the ground. Direct forward visibility at ground level is 0 for the first 30 feet. That zone is covered by camera and radar. You are driving a building. Width is the second disqualifier. At 31 feet, the 797F covers 2 full 12-foot lanes and still overhangs both shoulders. Federal oversized load limit is 16 feet before you need a state-level superload permit. At 31 feet, you are not filling out a permit application. You are calling the governor's office and closing a highway corridor. Now here is the transport reality most people skip over. You cannot drive a 797F out of the factory gate. Caterpillar builds these in Decatur, Illinois, and they ship in components. The mainframe goes on a specialized heavy-haul trailer. The dump body is sectioned and hauled on 2 more. The engine assembly, over 20 tons on its own, goes on a dedicated lowboy with a pilot car escort. The tires go on flatbeds. You are looking at 8 to 12 separate permitted loads to move one truck from the factory to the mine gate, where a Caterpillar field service crew reassembles it on site. The transmission is a 6-speed automatic. On long downhill grades, the electromagnetic retarder generates so much heat that mine haul roads run dedicated water truck circuits just to manage the dust and surface degradation that retarder heat creates. The verdict is straightforward. The 797F was engineered from the ground up for purpose-built mine infrastructure. Mine haul roads are designed specifically around its axle loads and tire footprint. Nothing about this machine is an oversight. It is precisely right for where it operates. On a public road, everything around it fails. Machine number 2. The Bagger 288 bucket wheel excavator, manufactured by ThyssenKrupp and commissioned in the Hambach lignite mine in Germany. Total operating weight, 45,500 metric tons, just over 100 million pounds. Length, 721 feet. Width across the 3 crawler track units, approximately 70 feet. The bucket wheel itself is 70 feet in diameter, carrying 20 individual buckets, each holding around 6.7 cubic yards. At full production, the Bagger 288 excavates 240,000 cubic meters of overburden per day, every 24 hours. Calling this a vehicle is technically accurate and practically meaningless. Rated travel speed, 0.4 miles per hour. It does not steer with a wheel or a joystick. It steers by differential drive. Independent electric motors on each crawler track unit fed from a 16,000-volt trailing power cable. To execute a turn, the control system commands different speeds across the 3 track units, while hydraulic leveling cylinders at the pivot points keep the superstructure level. A full turning maneuver takes hours. Width alone permanently eliminates public roads. A standard highway overpass is 40 to 50 feet wide between parapets. The bagger's crawler footprint at 70 feet does not fit under it, over it, or through it. Now the famous crossing, because this is where the engineering gets instructive. In 2001, the Bagger 288 needed to relocate across the B477 Federal Highway near Kirpen, Germany, to access a new excavation zone. Dismantling a machine of this complexity was not a realistic option. It took over a year of planning just to arrange the crossing. The solution was to bury the road. 3 feet of compacted sand and fill material was laid over the asphalt surface. Not to protect the machine does not care what it crosses, but to protect the road. Hardened steel crawler grousers at 100 million pounds of contact load on bare asphalt would have shattered the subbase in a single pass. The sand distributed the ground pressure across a wider area and prevented direct grouser contact with the road surface. The crossing took approximately 3 weeks. The highway was then excavated back to grade and resurfaced. From an operations standpoint, the Bagger 288 is less like running equipment and more like managing a small industrial plant. There is no single operator seat. There is a control room. The operator monitors bucket wheel RPM, conveyor loading, crawler drive amperage, and ground bearing pressure simultaneously while coordinating with surveyors and mine planners in real time. The verdict: the Bagger 288 is not a vehicle that happens to be large. It is a stationary mining installation that happens to be capable of slow movement. The road ban is not a technicality. It is a physical impossibility. Machine number 3. The Liebherr LTM 11200-9.1 all-terrain mobile crane. Maximum lifting capacity, 1,200 metric tons at a specified radius with full counterweight and outrigger deployment. Main boom, 328 feet in a 7-section telescoping configuration. Maximum tip height with luffing fly jib attached, approximately 623 feet. The carrier has 9 steerable axles. Total carrier length, 73 feet. Width in road configuration, just over 10 feet, which is legal. Weight in road configuration without boom, counterweights, or hook block, approximately 108 metric tons. Here is where this machine deceives people. On the road, in its stripped configuration, it looks like a very large truck. It signals, it brakes. In some jurisdictions, with the right permits, it can travel point to point. But that configuration has nothing to do with its working state. To lift at rated capacity, the 11,200 requires 202 metric tons of counterweight. That travels on 2 or 3 separate lowboy trailers. The main boom, over 150 tons, travels on 2 telescoping Goldhofer trailers. The luffing fly jib goes on another. The hook block, outrigger pads, and rigging hardware fill a 5th. You are looking at 5 to 7 vehicles in convoy before this crane lifts anything. The axle weights on those transport loads require superload permits in every jurisdiction. Many require a pre-approved route survey certified by a licensed structural engineer who physically inspects every bridge on the route for current load-bearing capacity, not rated capacity, current capacity, accounting for age and condition. Here is what that looks like in the field. 30 years ago, I had a permit denied in West Virginia because a 1957 steel stringer bridge over a secondary road had section loss from corrosion you could put a finger through. The rated load was still posted at 40 tons. The engineer on the ground measured actual web thickness, half of what the original drawing specified. No permit. We rerouted 73 miles. That is not bureaucracy. That is physics catching up to deferred maintenance. The outrigger pads are worth understanding. At maximum pit configuration with outriggers spread to approximately 52 feet, the load on each outrigger pad can exceed 700 metric tons on a single contact area. Standard crane mats, laminated hardwood or fabricated steel, are used to spread that load and prevent the outrigger from punching through the bearing surface. Ground preparation for a critical lift with the 11,200 is a multi-day operation involving geotechnical assessment of subsurface bearing capacity at each outrigger position. In the cab, the Licon load management system monitors actual boom angle, current radius, and line pull on each drum in real time, comparing against the load chart for the exact configuration in use. If the operator attempts to exceed a load chart limit, the system does not warn. It stops the lift. Some operators find this frustrating. At 1,200 tons, a load chart violation is not a near miss. It is a structural failure event. The verdict: the LTM 11,200 is road legal as a carrier and road banned as a working crane. Its modular design, built so that every major system separates and transports within legal limits, is not a compromise. It is the design intent. The fact that it travels in pieces is how it gets to the job site at all. Machine number 4. The Komatsu D475A-8 track-type tractor. Engine: Komatsu SAA 12V140E7, producing 1,150 horsepower at 1,800 RPM. Operating weight: 253,000 pounds, approximately 115 metric tons. Blade width on the semi-U configuration: 24 feet 3 inches. Blade capacity: 44.4 cubic yards. Track shoe width: 35.4 inches. Rear ripper penetration depth: up to 71 inches in the right material. The road ban on the D475A comes down to two separately disqualifying issues. First, track shoe design. The D475A runs hardened steel grousers, 3-inch machined cleats on every track shoe. On compacted overburden, engineered fill, and soft rock, those grousers are what allow this machine to push 44 cubic yards of material at a time. They dig in and hold traction under full blade load. On asphalt, those same grousers function as hardened steel chisels under 253,000 pounds of machine. They do not leave marks. They remove the road surface. The top 2 to 3 inches of bituminous material shear off, and the base course is exposed. There is no speed at which this becomes acceptable. 1 mile per hour causes the same damage as 10. Military tracked vehicles use bolt-on rubber track pads specifically for road movement. The D475A has no such configuration because road travel was never part of its design brief. It is a mine and quarry machine and nothing else. Second, blade width. At 24 feet 3 inches, the blade is wider than 2 standard 12-foot lanes. Even if you solve the grouser problem, the blade intersects with guardrails, utility poles, signs, and oncoming traffic at the same time. The blade must be removed before the machine can be loaded for transport. Moving a D475A between sites means removing the blade and push arms, separate lowboy. Removing the ripper shank and its hydraulic cylinder assembly, separate trailer. The bare chassis then goes on a low-profile hydraulic modular trailer with a minimum of 12 to 16 axle lines to bring per axle weight within superload permit limits. And in many counties, certain bridge structures still cannot be used regardless of the trailer configuration. From the operator's seat, the D475A is a deliberate machine. The cab sits high enough that direct ground-level visibility at the blade corners is limited. You learn to read the blade by feel and instrument. The hydraulic response is intentionally dampened at this operating weight. You do not make quick corrections. You make committed blade inputs and let 115 metric tons of momentum do the work. Under full load in hard-ripping material, the engine note is a sustained low-frequency resonance. You feel it in your ribs before the sound reaches your ears. The machine is talking to you through the seat. The verdict: the D475A's road ban is the direct result of design choices that make it exceptional at its actual job. The steel grouser outperforms rubber pads significantly in hard material. Nobody gave up road capability by mistake. They gave it up on purpose to get the pushing and ripping performance this machine delivers. Machine number 5. The Case IH Quadtrac 715. A 4-track articulated agricultural tractor. Operating weight: approximately 65,000 pounds before ballasting. With full ballast for heavy tillage, up to 85,000 pounds. Engine: FPT Cursor 18, 6 cylinders, 845 horsepower. Track shoe width: 36 inches per track, 4 tracks total. Overall width with tracks set for fieldwork, 20 feet. Length: 26 feet. Top road speed: approximately 24 miles per hour, if you could legally get it there. Now the road problem. At first glance, 85,000 pounds sounds heavy but not obscene. A loaded dump truck weighs that much. But the Quadtrac runs 4 rubber tracks, each with a contact patch roughly 36 inches wide and 9 feet long. That enormous footprint puts ground pressure down around 8 to 10 psi, less than a person walking. The road itself is not the issue. The operator is not going to punch through asphalt. The width is the immediate disqualifier. At 20 feet, the quad track covers a full 12-foot lane and still hangs 4 feet into the opposing lane. Most rural highways have 10 to 12-foot lanes. On a 2-lane road, a 20-foot machine forces oncoming traffic completely onto the shoulder or into the ditch. There is no legal way to center it. You pick a lane and occupy the other one by default. But the real problem, the one that gets farmers pulled over and ticketed, is the tracks themselves on dry pavement. Rubber tracks on an 85,000-pound machine do not damage the asphalt the way steel grousers do. They also do not turn the way tires do. When a quad track corners on pavement, the tracks scrub laterally. The operator feels the whole machine shimmy. With rubber on dry asphalt, that scrubbing builds up heat in the track lugs and deposits fine black rubber dust in a curve behind the machine. On a sharp turn, the inner tracks can actually lift a few inches off the pavement because the articulation joint torques. Highway patrol officers see an 85,000-pound machine lifting a corner in an intersection, and they write every citation they can find. The transport reality is instructive. Most quad tracks never travel more than 10 or 12 miles between fields. That trip is done on back roads at low speed, often with a pilot vehicle, and the operator plans the route to avoid right-angle turns whenever possible. For longer moves, the machine goes on a lowboy trailer. The tracks alone, each one a self-contained rubber and steel assembly, cost about $12,000 per set. Road scrubbing wears them out prematurely. Farmers do not road the quad track because it is fun. They road it because the fields are far apart and the trailer is on the other side of the county. From the operator's seat, the quad track is surprisingly nimble for its size. The articulated steering means the rear half follows the front half in a bend, not a pivot. On soft soil, that gives you a smooth ride and excellent flotation. On pavement, it means the back tracks run in a different line from the front tracks, doubling the scrubbing effect. Experienced quad track drivers learn to take curves wide and slow, almost like backing a trailer, to keep the machine settled. New drivers leave black donuts at every intersection. The verdict: the quad track is not banned outright in every jurisdiction, but it operates in a legal gray zone that effectively bans it from anything but local back roads. It is too wide for standard lanes. It scrubs corners wrong. And unlike the mining machines on this list, it was actually designed with occasional road travel in mind. But physics still makes that travel expensive, slow, and citation-prone. That is the difference between a machine that ignores roads and a machine that apologizes for using them. A question for the operators watching this. We covered the D475A and the deliberate trade-off of road capability for ground performance. The steel grouser is the reason that machine rips and pushes the way it does. If you have run both the D475A and any mid-tier dozer that uses rubber track pads for occasional road travel, your D8s, D9s, D10s, or the Komatsu D275 series, I want your real-world read. Does the rubber pad configuration cost you measurable pushing and ripping performance on the hardest materials? Or is the difference smaller in the field than the spec sheets suggest? Drop your answer in the comments, not opinions, seat time. And for the crane operators, on a large all-terrain crane move across older bridge infrastructure, what is the most restrictive element in the permit process? Axle loading, bridge ratings, or overhead clearance? I gave you my answer from West Virginia in 1994. I want to know what current field conditions look like. 5 machines, 5 road bans, each one for a different engineering reason. The 797F, ground contact pressure and gross vehicle weight that exceed highway infrastructure design loads by an order of magnitude. The Bagger 288, 100 million pounds and 70 feet wide, a concept that makes the idea of a public road irrelevant. The Liebherr LTM 11-2000, road legal as a bear carrier, a 5 to 7 vehicle convoy in any working configuration. The Komatsu D475A, steel grousers and a 24-foot blade designed without road travel in mind, on purpose. The Case IH Quad Track, a machine that apologizes for every mile of pavement it touches, too wide for its own good and wrong-footed on every corner. None of these machines carry a road ban because of bureaucratic oversight. Every one of them represents an engineering trade-off made deliberately. You gave up road compatibility to gain payload capacity, dig production, lift rating, or tillage depth. Engineers made those calls knowing exactly what they were doing. Next time we are going to look at a machine so large that the permitting process to build it required authorization from 3 separate national governments. You will recognize the name. It has not changed much since the 1960s, and there is a specific reason for that. Like and subscribe if this is the content you are here for. I will see you on the next